Hello students, welcome back. Earlier we have studied decision making under what is the concept of decision making and decision making under uncertainty. In this video we are going to study decision making under risk and what is the meaning of decision tree analysis. So what is decision making under risk? In this type of decision making environment, the decision maker has the sufficient information to assign probabilities to the likely occurrence of each outcomes. And knowing the probability distribution of outcome, the decision maker needs to select a course of action. So we have first a criteria under decision making under risk is expected monetary value. An expected monetary value for a given course of action is obtained by adding payoff values multiplied by the probability associated with each state of nature. And the procedure is, first we have to construct a payoff matrix listing all the possible course of action and state of nature, and then enter the conditional payoff values associated with each possible combination of course of action and state of nature along with the probabilities of occurrence of each state of nature. Then we have to calculate expected monetary value for each course of action by multiplying the conditional payoff with the associated probabilities and then adding these weighted values for each course of action. And then we have to select the course of action that yields the highest expected monetary value. So the illustration is here. Our management is faced with the problem of choosing one of the three products for manufacturing. The potential demand for each product may turn out to be good, moderate or poor. The probabilities for each of these three states of nature are estimated as product XYZ is given, and the nature of demand, whether it is good, moderate or poor, is given, and the estimated profit or loss under three states are given for the product X, Y and Z. Now what you have to do, you have to prepare an expected value table and advise the management about the choice of product. So what first we will construct expected monetary value table. So first we will write the nature of demand, that is good, moderate or poor, that is E1, E2 and E3, and the products, that is the act X, Y and the acts for X, Y and Z. So what we will do, we will multiply the estimated profit or loss with the associated probabilities. Like for product X, the value is 30,000 and the probability associated is 0.70. So we will multiply 30,000 with 0.70. For the state of nature moderate, the profit estimated profit is 20,000 and the probability associated for the product X is 0.20. So we will multiply 0.20 with 20,000. Similarly we will do for every product, and then we will add X product nature of demand, whether it is good, moderate or poor, then for Y product and then for Z product. After adding all these values, we will see which is the highest value. The highest value is 43,000. So the advice given to management is expected monetary value of Y is maximum. Hence the management should choose product Y for manufacturing. Then the second criteria under decision making under risk is expected opportunity loss. It is an alternative decision criteria for decision making under risk. Here, the difference between highest profit and the actual profit due to choosing a particular course of action in a particular state of nature is taken. So expected opportunity loss is the amount of payoff that is lost by not choosing a course of action, resulting to minimum payoff in a particular course of action. The procedure is, first we have to calculate a conditional payoff value matrix for each combination of course of action and state of nature along with its associated probabilities. Then for each state of nature, calculate conditional opportunity loss, that is by subtracting each payoff from the maximum payoff. Then we have to calculate expected opportunity loss for each course of action by multiplying the probability of each state of nature, and then select a course of action for which expected opportunity loss is minimum. So the illustration is here. Calculate expected opportunity loss for the following payoff table. The acts are given, A1, A2, A3, event probabilities are given, and there are 3 events. So first, what we have to do first, we have to prepare the opportunity loss table. And for this purpose, we have to deduct the highest payoff in the row of each event. And the highest payoff for first event is 25, for the second event is 440, and for the third event is 750. So the opportunity loss table will be, for the first row it will be, because the highest payoff is 25, that is 25 minus 25 0, 25 minus minus 10, that will be 35, and 25 minus minus 125, that will be 150. Then for the event E2, the highest payoff in this row is 440, so we will subtract 440 from 400, 440 from 440, and 440 minus 440, and similarly we will do for E3. So in this manner we will calculate the opportunity losses. Now the expected opportunity loss will be calculated by multiplying opportunity loss of each combination with the probability of the event involved in the combination. So the probability for event E1 is 0.10, for event E2 it's 0.70, and for the event E3 it's 0.20. So we will multiply these probability with the acts A1, A2 and A3. So the value then, for example, 0 multiplied by 0.10 will be 0. 0.10 multiplied by 35 will be 3.5. 0.10 multiplied by 150 will be 15. For the event E2, the probability associated is 0.70. For in this row, when we will multiply 0.70 multiplied by 40 comes out to be 20. 0.70 multiplied by 0, it comes out to be 0. 0.70 multiplied by 40, it comes out to be 28. Similarly, we will calculate for E3. After the values will come out to be 20, 2.0 and 0. Now we will add the act A1, act A2 and act A3. Now of all these acts we will choose the minimum value. Now expected value of perfect information. Here the formula uses, we have to calculate expected value with perfect information minus maximum expected monetary value. So the illustration here is A1, A2, A3 are the acts, and S1, S2, S3 are the states of nature, and the probability associated with states of nature is, for S1 it's 0.50, for S2 it's 0.4, and for S3 it's 0.1. So the solution is, we have to calculate, first write a payoff table, the states of nature, and the acts are mentioned over here, and then we will calculate expected monetary value for A1, expected monetary value for A2, and expected monetary value for A3. That is, when the probabilities which has been assigned for S1, S2, S3, we will multiply with the acts. That is 0.50 multiplied by 30, 0.4 multiplied by 20, 0.1 multiplied by 40. These because 0.5 is the probability associated with S1, 0.4 is the probability associated with S2, and 0.1 is the probability associated with S3. And for A1 we will calculate expected monetary value by multiplying 30, 20 and 40, and the value will come out to be 27. Similarly, we will calculate for A2 and A3. Now what we have to do, we have to select the highest expected monetary value, that is A2, that is we will select 29.5. Now what we have to do, we have to calculate expected value with perfect information, and for this we have to select maximum profit of each state. For S1 the maximum profit is 30, for S2 the maximum profit is 35, and for S3 the maximum profit is 40, and the probability associated with S1, S2, S3 is 0.5, 0.4 and 0.1 respectively. Then we will calculate the expected value, that is probability multiplied by profit. Then we will add these values, so the answer will come out to be expected payoff with perfect information is equal to 33. Now we will write the formula, that is we have to calculate expected value of perfect information is equal to expected value with perfect information minus maximum expected monetary value is equal to 30, that will be equal to 33 minus 29.5, and the value will come out to be 3.5. Now the topic is decision tree analysis. So what is a decision tree? A decision tree is a graphical model of a decision process. It is also called as decision tree diagram, decision diagram, or decision flow diagram. Like a tree, decision tree also possesses a number of branches which flows from left to right. It should be noted that a decision tree is derived from a physical appearance of the usual graphic representation of this technique. Branch is used for each alternatives and sub branches for each possible outcome of chance event that can occur from the alternative. So a decision tree consists of nodes, branches, probability estimates, and payoff. There are two types of nodes, that is the decision nodes and or the act node and the chance node. A decision node is represented by a square and represent a point of time where a decision maker must select one alternative course of action among the available course of action. And the chance or the event node is each course of action may result in a chance node, and the chance node is represented by a circle and indicate a point of time where the decision maker will discover the response to his decision. Now the branches emerge from and connect various nodes and represent either decisions or states of nature. And there are branches, that is decision branch. It is a branch leading away from decision node and represent a course of action that can be chosen as a decision point. Then there is a chance branch. It is a branch leading away from decision node and represent the state of nature of set of chance event. The assumed probability of states of nature are also written alongside. Then we have a terminal branch. So any branch that makes the end of decision tree is called a terminal branch. So here is an illustration of a decision tree. Decision tree can be further divided into stages like single stage decision making under uncertainty and a multi-stage at a sequence of decisions are taken. So we in square we have decision nodes, then we have a course of action, that is decision branch, then we have chance node, then we have again state of nature, that is chance branch, and it is decision tree is continued in this process. So here is an illustration that you are given a following estimate concerning a research and development program. So the decision that you have to take whether to develop or do not develop a research and development program. The probability of decision is 0.5 for both whether to develop or not to develop the program, and there are three outcomes associated with each of the decisions, and the probability of outcome is given 0.6, 0.3, 0.1, 0.0, 0.0 and 1.0, and the payoff value of outcome is also given. Now what you have to construct, a decision tree from the above data. So the decision tree of given problem will be what first we have to calculate, we have to draw a square, that you have to take a decision because square symbolizes the decision point from where the decision making will take place. So the two course of action will be taken, whether to develop or not to develop the project. Then we have the outcomes. There are three outcomes associated with to develop the project and three outcomes associated with do not develop the project research and development project. Now the probabilities are also associated with it. So what we have to do, we have to multiply the probability of decision with the probability of outcome. Then the payoff values are given, and with the help of the probability and payoff values we will calculate the expected payoff by multiplying the probability value with the payoff value, that is 0.3 into 600, 0.15 into minus 100 minus 15 will come, 0.50 into 0 will come, and we will add this value and 165 will come. Similarly we will do for do not develop the product, and the value will come out to be 0. So the highest expected monetary value is 165. So So the decision which will be taken is to develop the research and development program. Okay students, thank you.